Okay, well, what I'm going to do this evening is I'm going to talk about some of the missions that happened in 2021, some of my highlights really, some flashbacks, and then tell you what's up and coming in 2022. Now, there's so much coming up in 2022, it's difficult to cover it in this particular session, but it's just a taster really of what we got to look forward to. But me, who am I? I understand it's customary to introduce yourself when you're talking for the first time in this forum. So I'm Philip Price. I'm a spaceflight enthusiast, and I have been for probably about 35 years now. I'm a fellow of the Royal Astronomical Society, and I'm committee chair for my local astronomical society in Luton. I do lots of outreach events with scouts, cubs, schools to get them their astronomy badges, and also help with the GCSE curriculum. I'm also a spaceflight speaker for the Virtual Astronomy Club with Dave Eagle, which was started up during lockdown. So if you've come along to one of those, you've probably seen me do 1 or 2 talks. I'm also a space writer for Go Space Watch, because I've just finished my first article that's going to be published. So if you go to gospacewatch.co.uk, you'll be able to sign up for a magazine called Capcom, and one of my articles will be in the January issue. And for the OU, well, as I'm a spaceflight enthusiast, I know all about the missions and what's happening and what they're doing, but the Open University gives me the opportunity to learn the science behind those missions so that I can understand why they're doing what they're doing, why they're going where they're going, and what they do when they get there. So that's me. So what actually happened in 2021 then? Well, let's have a look at the numbers. So as you can see, we had 133 catalogued launches across the world in 2021, which, considering the pandemic, is up on previous years, as you can see in the purple numbers there. So that increased in activity is more commercial flights that have been taking place, lots of Starlink launches that have been ramping up, and we've even got another one going tonight. If you want to log on to SpaceX later on tonight, you'll be able to see a SpaceX launch go up. We've got more Earth observation satellites, with us doing more environmental activity and looking after the planet. NASA are now concentrating on that, and of course more countries are getting involved as well. So it's not just the big 4 or 5 space agencies. Everybody wants a piece of the space pie, including, hopefully in 2022, the UK. Iran had a go in 2021. So yes, we've got all those to look forward to. And in terms of manned space flights, that's a similar story. In 2019 and 2020, there was 12 space travelers to space, but in 2021, we had 48. Now that again is due to the increase in commercial activity. You had Virgin Galactic, most of those were suborbital. Blue Origin, again, suborbital. The Inspiration 4, that was a mission that was funded by Elon Musk. They raised money for charity, and they went around the Earth. And of course, the Crew Dragon now carries 4 passengers instead of 3. So instead of cramming people into the Sputnik with 3 astronauts, you can now get 4. So it's an extra astronaut each and every time. So those numbers are just going to grow and grow and grow. And considering we've already had lots of discussions over how much space debris we've got up there and how much activity there is, it's just going to get even worse. So we just need to be a little bit careful, as long as we do it in the right manner. So this is my review of 2021. So these are some of the highlights that I've got. Probably the biggest highlight of them all was, well, at the beginning and at the end. Right at the beginning, we had all the Mars missions. So they all took off in July 2020. So we had the Mars rover copter, we had the United Space Agency with their orbiter, and then the Chinese with their orbiter, lander, and their rover. So United Arab Emirates, they launched or launched their Hope mission, which was a $200 million mission that they called the Emirates Mars mission. So that was went round to Mars in February, and it was the first mission to look at the upper atmosphere and the lower atmosphere to understand why hydrogen and oxygen are being lost. So it was a sort of like a follow-on from what Maiden had discovered. Tianwen-1, so this was the Chinese mission, and that consisted of an orbiter, a lander, and a rover, which was quite impressive. They were successful. They were the third nation to land successfully on Mars, but they were the first mission to do all three at the same time. And if anybody knows how difficult it is to get to Mars, that was quite a feat. And then, of course, the pièce de la résistance, the Perseverance rover. First thing we've landed that was over a ton, because Curiosity was just under a ton. It used the same shell as the Curiosity rover, but had added extra features that they'd built in to when they developed it. So it landed in Jezero crater, because it was at the base of a delta down here, so they wanted to, they know that there was possibility of seeing life here, and they know that was a delta because you can see where the crater wall has been exposed. We got the Mars helicopter was also on there, the Ingenuity, and it did its first maiden flight on another planet, first powered flight on another planet, and they likened it to the Wright brothers flight. Now, all of that was leading up to the sample return mission. So this was the Perseverance that was landing, and it's collecting samples that would then hold on to or drop off on the surface, depending on which is best. And then another spacecraft will come back. A little rover will come and collect those little samples and then fire them back to Earth, so bring some Mars back to Earth. So that's going to be happening. They reckon ESA are going to start sending that out in 2026 and get the samples back here by the early 2030s. So that was Mars. Next one to talk about is DART. So DART is the double asteroid redirection test. Now that launched this year, but I'm going to spend a little bit more time on this because it's actually going to affect next year as well. So we've sort of got a double header of 2021, 2022 going on here. So it's a spacecraft that's going to be deliberately crashed into a double asteroid system, the Didymos system. So they're going to crash it into the smaller one and then see if any effect has been happened on its orbit, so that if it has, they can then see if they can redirect asteroids if they see them coming towards the Earth. So this is a very safe exercise. Didymos is coming nowhere near us. The reason why they've chosen this target is A, it's near us, and secondly, they can see the effect by crashing into the smaller one in relation to the larger one. So why are they doing this? Well, this is a report of all of the impacts that we've had between 1988 and 2019. And you can see here that you've got the one that landed in Russia. That was, blimey, nearly 10 years ago now. That's hard to believe. So that one then was about 20 meters wide. You've got the Tunska one, which is probably the largest one that we've had in modern times, over 100 years ago now. That was about 100 meters wide. And then the dinosaur killer one that was 15 kilometers wide. So putting that into perspective, the really large ones we can see because we can track them fairly easily because they're so large, and we know that there aren't any potential hazardous asteroids that are that big coming towards us in the near future, certainly within the next 100 years. The smaller ones, okay, they will do some damage just like the one in Russia, but there won't be any risk to life because there wasn't any casualties in the Russian one. So the bit that they're targeting is this area here. So about the 100, just over the 100 meter, 150 meter diameter. So that then if they can see them come in and they've tested this, we can crash a spacecraft into it, divert it slightly, and the earlier we discover it, the more chance we've got of diverting it, because you only have to nudge it a little, but over time, that small adjustment in its orbit will mean that it will miss the Earth. So that's the plan, that's the mission, and why we're doing it. This slide is a little bit out of date now. It says it's got launched in June 2021, but it actually launched in November last year on a Falcon 9 rocket. One of the casualties of the pandemic. So it's also going to be testing some key technologies. So it's got Smart autonomous navigation. Now what that means is because you've got two asteroids that are very, very similar looking, it's going to automatically identify which one to crash into rather than it be chosen by remote control. You've also got a high-res imager, similar to the one that was on the New Horizons that went out to the Pluto and beyond the Kuiper belt. It's going to be testing ion propulsion engines. So give us a chance to have a look how they perform, and roll out solar arrays. These have been used on the International Space Station, but at the moment on spacecraft, the solar arrays unfold, whereas these will roll out like a blind that you have in your kitchen. So they'll be able to store them a lot easier and less risk of them getting tangled up when they unfold. So that mission is all part of our planetary defense mission, which you can see over here. And this one falls into the mitigate, as in to do something. Although I think this slide needs updating because I don't think the Arecibo looks like that anymore. But that's the slide that the planetary defense have got on this website. Now, the reason why this is important for next year is because the impact is going to take place, they say, on the 7th of October in 2022. And because it's only 6.6 million miles from the Earth, they reckon it could trigger an artificial meteor shower. So that will be something to look forward to. So October next year, date for your diary, and I'm sure it will be all over the news, but you heard it here first. So one of the other big things that's happened, obviously Christmas Day, great Christmas present for all us astronomers, was the launch of the James Webb Telescope. So this is its trek, and I know that the OU students have been tracking it because they've been putting it all on social media, and it's doing really well at the moment. Everything seems to be going on course. So when it gets over to its L2 point, it'll be going through its calibration and its cooling stages to make sure that in 6 months' time, once all of that's been completed, hopefully we will be seeing the first light pictures from this wonderful new instrument that we've launched and waited so long for. So that's 2021. Now moving into 2022. So there's quite a lot going on there. This isn't everything that's going on in 2022. These are just some things that I've picked out that are of interest. So it includes anybody that bought a ticket and read the brief, new technology that's going to be happening, new telescopes that are going to be launched, which includes the James Webb on that, because that's going to be operational in 2022, plus maiden flights of some brand new rockets and some engines. So, hot off the press, this happened, I think, about a week before Christmas. This was announced. Starship are going to try and launch, or Elon Musk is going to launch his Starship SN20, which will be the first orbital flight of this this new spacecraft, and he's going to try to do it as early as January. So that's going to be happening fairly soon. It's going to be the most powerful rocket that we've ever launched into orbit. It's going to be able to generate more than twice as much thrust as the Saturn V rocket. And you can see here that they've had to start putting the tiles on it, because the other ones were just tests. So this particular one's going to be going into space and out, and they need to put the tiles on to protect it coming back through the Earth's atmosphere. So that'll be something to look forward to. This one is a SLIM. This is called a Smart Lander for Investigating the Moon, which is a mission by JAXA, the Japanese space agency, for researching the pinpoint landing technology necessary for future landing probes, verifying on the moon surface and testing it to make sure that we can land exactly where we want to. So by creating this lander, any future missions, not just to the moon, but to any other planet, means they can pinpoint exactly where they want to land. So if they've got resources on a particular planet like the moon and we want to land near them, we can land as close to possible of those resources to make sure that we can make use of them. XRESM. Now this is an X-ray satellite, also by JAXA, the Japanese space agency, and what it will do is it will provide breakthroughs into the study of formation of the universe, outflows from galaxies, and dark matter. So the reason why they're launching it is it's a stopgap between downtime of observations, because the current ones, Chandra and the XSN, that's on the left-hand side there, and then the future missions over here on the right-hand side, you've got the Athena and the Lynx X-ray that won't be launched until late into the 2020s. And then we lost the Hitomi shortly after launch. So this particular XRISM will be a stopgap to make sure that we can still do X-ray telescope technology or X-ray telescope experiments during the time, and we don't have a blackout during the 2020s. JUICE. JUICE is an ESA mission. It stands for Jupiter Icy Moons Explorer, and it's a mission that will study 3 of the Galilean moons of Jupiter, Ganymede, Callisto, and Europa. It's going to be excluding the volcanically active Io, because those 3 are thought to have significant bodies of liquid underneath because of their icy surfaces, and they're potentially habitable environments. So that we're interested in going out there and having a look. And this mission will overlap the NASA's Euro Clipper mission, which will be launching in 2024. So they'll complement each other. So it's due to launch in June 2022. It's going to be about a 7.5-year cruise to get to the Jovian system, and then it's going to spend 3.5 years there. In September 2032, it will enter an elliptical orbit around Ganymede, where it will study its composition, magnetosphere, and all the other things while it's there. And then when the spacecraft's propellant does run out, it will be deorbited and impacted into Ganymede in 2034. It's got all the normal stuff on it, spectrometers, altimeters, interferometers, magnetometers to measure everything. But probably the most interesting one and an unusual one is this one, REAM, which is the ice penetrating radar, so that it can get underneath that icy surface and give us an idea of exactly what's underneath it. Now, Artemis is the mission that's starting us to get back to the moon. This was delayed from late last year. Was due to launch in February this year, but has been pushed back even further now to March. This Artemis 1 mission will be the test run. It will be sending, the first time we've ever using the SLS and the Orion together. It will send it unmanned around the moon and back again. So it'll be like an unmanned Apollo 8, really, just to test it all out, which is really exciting for somebody that was too young for Apollo. To get to see all this again will be absolutely amazing. So I can't wait for that to go up. But it's also going to be carrying some passengers. So it was due to have 13 CUBESATs on board. But unfortunately, 3 of them have missed the deadline to be made. So it's now going to only carry 10. Now, the CUBESATs are little tiny satellites that will sit inside the payload there, the adapter ring, and they will be doing their own individual science. So all they're doing is they're using Artemis as a ride to get to space, and then they'll all do their own individual science while they're there. So here's the list of all of the missions that are on it. So a lot of them are to do with the moon. You've also got some that are going around the sun, but this particular one up here, Near Earth Asteroid Scout, or NEAR Scout as they'd call it. So I'll give you an example of the sort of thing. So this is NEAR Scout. So this is it all folded up, and then when it opens up, it's going to have a sail that's the size of an American school bus that will then take it to a near Earth asteroid where it'll be able to scan it, take some photos, and send some data back. So it's going to be testing, intercepting near Earth objects, near Earth asteroids, and testing the technology to see if we can do it cheaply while piggybacking on other missions on rockets that are going up. So CAPSTONE Now, I know this has been mentioned before, and we were hoping to do a live launch party, but it keeps getting pushed back and back and back. So this is a mission that's been awarded to Advanced Space in Boulder, Colorado by NASA. And it's a CubeSat that will be replicating the orbit of the Lunar Gateway when it goes up there. So it's an NRHO orbit, which stands for Near Rectilinear Halo Orbit. They reckon it's going to be launched in March 2022, and it's going to be doing a 3-month trip to the moon, and then it's going to spend 6 months there collecting data during its demonstration. It'll be the first spacecraft to operate in this particular orbit around the moon, and while in this unique orbit, it will be able to rotate together with the moon as it orbits the Earth, and it passes near the pole every 7 days of the moon. So this is the orbit itself. As you can see, it's quite unusual. It works out that it's a stable orbit that will use little effort on fuel. So it uses the balance point between the Earth and the moon's orbit to help keep it there. It'll always be looking at the Earth. So as it's going round, it's always pointing towards the Earth. So you get none of the blackout that you used to get in the Apollo days. You can see it goes close to the pole, so it's easy to go down onto the surface of the moon when it's at its nearest point. And it's also going to trial autonomous positioning using the Lunar Reconnaissance Orbiter, so it'll be able to work out where it is on its own rather than us having to look at it all the time. So yeah, Capstone, and hopefully, if that goes well and the orbit looks all right, we'll be able to launch the Gateway into the same orbit. So I promised you maiden flights, and we've got a whole string of them coming up in 2022. The first of which is the maiden flight of the Ariane 6, which is the follow-on from the Ariane 5, which is currently run by ESA and Ariane Space, mainly launching from Kourou in South America. So this is the Ariane 5 family, and the 2 variants here on the left-hand side will have 2 different versions. One will be the A62, which has got the 2 rockets on the side, and one will be the A64, which has got the 4 rockets on the side. So it's Ariane 6 with 2 rockets, Ariane 6 with 4 rockets. There we are. It's not rocket science, is it? Well, it is, but it isn't, if you know what I mean. So this is it compared to the Ariane 5. So at the moment, it can carry the larger version can carry 10 tons. The larger version will be able to carry up to 16 tons with the A64, and then the Ariane 5, currently carrying about 3.5 tons, will be able to carry nearly 7 tons. So we'll be able to carry larger payloads into orbit, or possibly even multiple payloads, more of them, as long as they're small enough to fit in the fairing. The Boeing Starliner. So this was supposed to have been one of our live launch parties back in August, but it got pulled because they noticed that there was some problems with valves. The valves were sticking. They've since fixed the valves, and they reckon they'll be able to do another launch later on this year. So we'll be waiting for that. The Boeing Starliner is it's Boeing's version of what the Crew Dragon is doing at the moment, but it has to pass 3 tests before it's allowed to be operational, according to NASA's rules. So it needs to be able to do a launch orbit test, which it has passed. This will be its unmanned test, and then it needs to do a manned test. But once it's got past this stage, it will then be passed to be able to carry a crew, just like the demonstration, the crew demonstration one did with Bob Behnken and Doug Hurley for the Crew Dragon. So yes, looking forward to that. And it's really important that NASA tries to persevere with this, because well, Boeing needed to get a return on investment for all of the effort that they've put into it, but NASA also need a backup or a second option to go to the International Space Station should something happen to SpaceX, because that was the problem that they had when the shuttle was grounded. So at the moment, they're only relying on the Crew Dragon. Should something happen to that, they won't have any way of getting backwards and forwards to the ISS unless they use the Soyuz again. So they're really desperate to get this up and running. So yeah, so in October, the NASA engineers said that they've managed to fix all of the valves, and hopefully during the first half of 2022, we'll be able to launch the Starliner and see that go, and hopefully get it as a live launch party 12 months after we originally asked. Something else that's going up, so Blue Origin, they currently have a suborbital rocket, the New Shepard, which is what they've been using to ferry some people backwards and forwards to the edge of space. This is the New Glenn, which is a two-stage rocket. It stands about 322 feet tall, and again, it's named after another astronaut, John Glenn, just like the New Shepard was. But this is a heavy lift vehicle that will be capable of carrying people and payloads into orbit. So this is what they need to do. They need to go to an orbital rocket rather than just the suborbital that they've got now. So the first stage of each New Glenn is reusable. They're estimating it can be used up to 25 times, and it can carry 50 tons into orbit. Now they have pushed the debut or its launch back, and it's now due to be the last quarter of 2022. So hopefully that will go this year. But something to get really excited about, Launch UK. We may have our first launch from UK soil this year. We have done it before from Woomera in Australia back in 1971. But unfortunately, we've not actually launched anything into space for orbit from the UK. So it's going to come from one of these people. So Skyroarer. Now, Skyroarer has been testing increasingly large rockets with short altitude since about 2018. So they're one of the new startup companies. And last year, it conducted the first rocket test on UK soil in over 50 years. So that's just the test, not the launch. As well as it launched its Skylark Micro, which is the smaller version of this, from Iceland last year as well. So they've agreed a decade-long deal for multiple launches from the Shetland Islands, so up here, an island called Unst, with the first to be happening in 2022. Another company that's due to be launching is ORBEX. Now, ORBEX are installing, over here, as you can see on the picture, a launch platform at a dedicated site in Kinloss, close to their headquarters, which is in Forres in Scotland. But the launch platform is known as LP1 and is expected to be fully operational as early 2022, is what they're saying. And the new launch platform will be able to support the testing of ORBEX's prime rocket, which you can see here, and transporting things into low Earth orbit. So there's two companies that are going to be launching into space, hopefully this year from UK soil. So there's lots of things happening in the UK because the UK Space Agency is now given the go-ahead. So these startup companies are now trying and testing, but these two are the ones that are way and above anywhere else at the moment. Another company called Black Arrow Space Technology, they are using a seaborne launch. Now, when you launch like ORBEX or Skyroarer, having to launch from land, you need to then own that land, you need to do all of the infrastructure and get all that. But these Black Arrow Space Technologies are going to be launching from a ship, which, funny enough, they're calling Spaceship. So they are new, and I don't know too much about them, but I'm going to be watching a webinar from Go Space Watch on the 26th of January that will tell us all about them and the latest. So their executive director, Paul Williams, will be going along. So if you want to join us for that, it's gospacewatch.co.uk and follow the link there. We'll find out all about that together. Virgin Orbit. Now, Virgin Orbit is Virgin's version of trying to get things into space. So what they're going to do is they've got sites all around the world, and one of those is based at Newquay in Cornwall, which is Spaceport Newquay. And what they do is Virgin Orbit have got a modified jumbo jet that they launch this rocket called Launcher 1. They mount it underneath the wing, and then they fly to a height of 35,000 feet, where it will then be fired off, dropped and propelled into space with the cargo. The cargo is here inside the fairing. So it can't launch as large payloads, but there is a launch happening next one from Mojave next week on the 12th at 6 o'clock. So hopefully, or sorry, it's 10 o'clock in the evening on the 12th. So hopefully, if you're around, you'll be able to go on and watch that. So yes, it's called Above the Clouds, which is the one that's launching next week. But the one from the UK should hopefully be launching in the summer of this year, because they want to try and coincide it with the Queen's Jubilee. So we'll be able to get excited about that. So it's not technically from UK soil, but the plane will be taking off from UK soil. So the rocket will be coming from the UK. So moving on to some more spacey technology now. Now we've got over the hype of the UK launches. This is the KPLO, which stands for the Korean Pathfinder Lunar Orbiter. Now it's a demonstration vehicle, hence the name Pathfinder, that will be launched to the moon, and it will be surveying the lunar resources such as water ice, uranium, and all the things of getting us a good idea of what the moon is all about. Now the mission's going to be launched on August this year on a Falcon 9, and it's going to be a two-stage mission. So the orbiter itself will perform at least 3 highly elliptical orbits around the Earth before it then goes off onto the moon and carries out its mission. So it's going to carry 5 instruments, and one of those is a NASA instrument. So 4 of them are from South Korea themselves, but NASA have piggybacked on there with what they call their shadow cam instrument that will require it'll acquire images of the shadowed regions of the moon in a high-res camera. So it's a 2-stage mission. So this is phase 1 of the Pathfinder, and the stage 2 of the Pathfinder will include a lunar orbiter, a lander, and a 20-kilo rover that will be launched together in 2025. So it's testing technology and also finding out about the moon, ready for us to go back there. Now JUNO, anybody that was listening to me talk last year would have been hearing that JUNO was going to be deorbited into Jupiter, but in January 2021, NASA extended its mission to September 2025, in which it's going to widen out its orbit so that it will be able to look at the inner moons of Ganymede, Europa, and Io. So this is its primary mission that was done, that was then finished, and then this is where the secondary mission took over. So it passed Ganymede in June last year, and then it's going to be moving in, and next year it's going to be passing Europa, probably near the end of 2022, and it's only going to be passing within 200 miles of Europa around about September next year, and then after that it will be going into to Io, and it will be able to collect information to help us towards the JUICE mission, which I mentioned earlier, and also the Europa Clipper launching in 2024, which is also going to the moons of Jupiter. PSYCHE. Now PSYCHE is a really interesting mission, and it's kind of an extension to a lot of the missions where we're going to asteroids at the moment. So we've got the Lucy mission that's going out there, we've had DART, which we're going out to, and PSYCHE is going to an asteroid called 16 PSYCHE. Now 16 PSYCHE was, it's a large asteroid. It was discovered in 1852, and it's called 16 PSYCHE because it was the 16th minor planet that we ever discovered. And its name, Psyche, is named after the Greek goddess of the soul, and it's the most massive metallic asteroid that we know of. So some of the things that we want to answer for it is it the core of an early planet? Because they, where it's just metallic, the outer part of it has been stripped away, they reckon, by a collision, and they're just left with this molten metal core. So is it the core of an early planet? How old it is it? And is it formed in a similar way to the Earth's core? So by examining that, it will give us an idea of how potentially our Earth formed, and also how the other planets formed that have also got a metallic core. So the interesting part of it is it's launching in August 2022. It's going to do a gravity assist past Mars in 2023 and arrive at PSYCHE in 2026. So again, another interesting launch that we'll be able to watch this year. It's going to be carrying an imager to do some photography, spectrometer, magnetometer, because where it being having a metallic core, we need to measure its magnetic field, and also a gravity science investigation instrument, because if it's like the Earth, we want to know how strong its gravity is. It's also going to be testing this DSOC, which is Deep Space Optical Communications, where it's going to be sending out laser beams to communicate with a ground station in California. And if those laser beam communications work better than the high gain antenna, they reckon it will be 10 to 100 times more efficient. So this will help us with communication in future missions. So again, new technology that's being tested. Along with PSYCHE 16 is JANUS. JANUS is a dual space probe. So there's two spacecraft that are going to go into binary asteroids. They're going to be launched in August 2022 as well, because they're going to be launched on the same Falcon Heavy as the PSYCHE space probe. And they're due to arrive at two binary asteroids in 2026. So the name Janus comes from the Roman two-faced god, and what it will do is it'll employ a pair of satellites that will be collecting data on asteroid systems that revolve around each other, a bit like the Earth and the Moon. So you can see here you've got the larger one, a bit similar to the Didymos system as well, so we can get an understanding of that. So yes, a lot of asteroid stuff going on at the moment, and what it will do is it will take different readings, instruments, infrared imager it's got, as well as visible photography, and sending those back to Earth. Now EUCLID, so mentioned new telescopes. This is another new telescope that's going up. So EUCLID will be a space telescope designed to look at the dark universe. So you've got dark energy and dark matter here. And what it will do is it will map out the large scale universe across 10 billion light years, looking at its history and how it was all formed. So to understand dark energy and dark matter, it will take accurate measurements of the accelerated expansion of the universe, and make 3D models and help us to understand how the universe was formed. It will study them using two methods. So the first is by observing the evolution of how galaxies all cluster together over the past 10 billion years. And the second will be, as demonstrated on here, the distortion of galaxy images. So an effect called gravitational lensing, due to the presence of ordinary matter and dark matter intervening between the gaps between these distant objects and these distant galaxies. Because 4.9% is ordinary matter, 26.8% is dark matter, and 6.8% or 68.3% is dark energy. That's the guesses. I mean, I'm not a cosmologist, but this is what we're hoping to find out and get a little bit more accurate and understand and detect its presence. Every year I get to talk about Mars. Because of its unique orbit, we line up with it for a perfect launch time every 26 months. So one year I get to talk about a landing, another year I get to talk about a liftoff, and then a landing, then a liftoff. So we had the landing this year when the Perseverance and the other missions landed. This time round in 2022, we get to talk about a launch. So this is ExoMars 2022. It's going to be in collaboration with Roscosmos, the Russian space agency, and it's going to be looking at signs of life. So the ESA rover, who are spearheading the rover part of it, it's named after Rosalind Franklin, who made great strides in understanding DNA, because this is going to be looking for signs of life, so it's very poignant. It was originally with NASA as part of the Mars 2018 program, but NASA pulled out due to budget cuts. So ESA had to team up with Roscosmos for Mars 2020, but due to parachute issues and the pandemic, they missed the launch window, which is very precise. It's now going to be launching from Baikonur in September 2022. So that's its estimated launch date, 20th of September 2022, and hopefully to arrive in March on the 10th of June the following year. So that'll be something to look forward to. So the mission consists of two parts. You've got the Roscosmos lander that will be bringing it safely down to the surface of Mars, and that's called the CUBESATS platform. And then you've got the ESA rover, which is called Rosalind Franklin, and it's got a 2-meter drill on it, so it'll be able to go down to the surface and into the surface further than we ever have done. It will be our third attempt, ESA that is, to land something on the surface of Mars. The previous failed Beagle 2 and the Schiaparelli, both unsuccessful. So hopefully, third time lucky for the European Space Agency. So that's everything that's happening in 2022. Really, really busy time. There's a lot going on above and beyond that, as well as the launches backwards and forwards to the ISS, and also the environmental missions that we're launching to keep an eye on the Earth. But it's also got some great anniversaries, 2022. So it's the 65th year of the launch of Sputnik 1. Now, some of you will remember some of these, and you'll probably realise, blimey, I didn't realise it was that long ago. So yes, very poignant year for that. It's also the 60th anniversary of the Kennedy Moon speech. We will go to the moon, not because it's easy, but because it's hard. So you remember that. Very, very poignant times that put the US on track to put man on the moon. It's also the 55th anniversary of the Saturn V. Also very poignant because we are intending to launch the SLS and the Orion this time round on its test mission, going back to the moon for the first time in 50 years. It's the 50th anniversary of the last man on the moon. So not only Apollo 16, but probably more poignantly Apollo 17, the last time we ever went there. And hopefully we get to go back there soon. The 45th anniversary of Voyager 1 and Voyager 2, still sending us some fantastic data. Now they've left the realms of the solar system. The landing of the Mars Pathfinder. So all of these Mars missions all come back to this very, very tiny rover that landed in 1997. And you think what we've got now, Curiosity and Perseverance, we're landing over a ton on the surface of Mars now. So we've made great strides in those last 25 years. It's the 15th anniversary of Dawn, which was the mission that went to Ceres and Vesta. Again, very poignant because we're going back to asteroids again. It's also like it's come full circle. 10th anniversary of the Curiosity rover landing. And this one, I can't believe it's 5 years ago. So it's the grand finale when we deorbited Cassini into Saturn. So that's 2022. I thank you very much for your time.